Hello everybody and welcome to my next session on this topic. Here we learn how to understand relations in mathematics. So you will learn what is a relation and how it is derived from a set, the different types of relation, equivalence relations and equivalence classes, and you will also learn how to check if a relation is reflexive, symmetric or transitive. If A and B are two non-empty sets and R is a subset of A cross B, then R is said to be a relation from A to B. So a relation is a subset of the Cartesian product of two sets. If R is a subset of A cross A, then R is a relation on A. So R is a relation on A means it is a subset of A cross A. Now we come to the types of relations. Let R be a relation on A. R is said to be reflexive if x belongs to R for all x belonging to A. In other words, you say x R x for all x belonging to A. So what is x R x mean? X belongs to R. R is said to be symmetric if xy belongs to R implies yx belongs to R. So in other words, R is symmetric if xry implies yrx for all xy belonging to A. So for symmetric, xy belongs to R implies yx belongs to R. If R is a relation on A, R is transitive. If xy belongs to R, yz belongs to R implies xz belongs to R. So R is transitive if xry, yrz implies xrz for all xyz belonging to A. So if R is transitive, xy, yz belongs to R implies xz belongs to R. That is how you remember it. R is an equivalence relation if R is reflexive, symmetric and transitive. Now, this is an important method to do mathematics. If something is true, we prove it. If something is not true, we give a counter example to prove it is not true. So coming back to equivalence relation, what is an equivalence relation? It is reflexive, symmetric and transitive. Let R be an equivalence relation on A, then the set of all elements such that X is related to A is called the equivalence class of A, denoted by this square bracket. So what is the square bracket? The set of all elements related to A. Coming to questions, R is a relation on 1, 2, 3 up to 10, defined by R is the set of all elements xy such that 2x minus y is 0. Determine whether R is reflexive, symmetric or transitive. Now 1, 1 does not belong to R because 2 minus 1 is not 0. So R is not reflexive. Suppose 1, 2 belongs to R. It belongs to R because 2 minus 2 is 0. But 2, 1 does not belong to R. Why is that? Because 2 into 2 minus 1 is not equal to 0. So R is not symmetric because 1, 2 belongs to R but 2, 1 does not belong to R. So here we are giving examples to show that it is not reflexive and not symmetric. Again 1, 2 belongs to R because 2 minus 2 is 0. 2, 4 belongs to R because 2 into 2 minus 4 is 0. But 1, 4 does not belong to R because 2 into 1 minus 4 is not equal to 0. So R is not transitive. So again we have given an example to show that it is not transitive. Question 2. R is a relation on the set of integers defined by R consists of the set of all elements xy such that x minus y is an integer. Is R an equivalence relation? Now x minus x is 0, which is an integer. So we can say that xx belongs to R for all x belonging to R. So R is reflexive. Now let xy belong to R. So here we have showed that R is reflexive by proof. So xy belongs to R means x minus y belong to z. So x minus y is an integer, so you can write x minus y as k into m, where m is an integer. So y minus x is minus k into m. That means yx belongs to R because y minus x is an integer. So we have proved that xy belongs to R implies yx belongs to R. So R is symmetric. So here again we have shown that by proof R is symmetric. Now let xy belong to R, yz belong to R. So this xy belongs to R means x minus y is an integer, yz belongs to R means y minus z is an integer. So if we add both, you get x minus y plus y minus z is an integer. What are we trying to prove? That xz belongs to R. So we have x minus z is an integer, that means xz belongs to R. So we have proved that xy belongs to R, yz belongs to R, implies xz belongs to R. Therefore R is transitive. Therefore R is an equivalence relation. What is an equivalence relation? It is reflexive, symmetric and transitive. Question 3. Determine whether R, which has a set of all elements AB, where AB belongs to natural numbers, A less than B is reflexive, symmetric or transitive. Now 1 does not belong to R because 1 is not less than 1. So R is not reflexive. Again we have taken an example to show it is not reflexive. Let 2 belong to R. It's true because 1 less than 2, but 1 does not belong to R because 2 is not less than 1. So R is not symmetric. Again, let AB belong to R, BC belongs to R. So A less than B, B less than C implies A less than C. So AC belongs to R. So R is transitive. Why? Because we have proved that AB belong to R, BC belong to R implies AC belongs to R. Question 4. Let A be the set of all elements x belongs to z such that 0 less than or equal to x less than or equal to 12. R is a relation on A given by R consists of the set of all elements AB such that AB belongs to A mod A minus B is divisible by 4. Is R an equivalence relation? And find the set of all elements related to 1. Now mod A minus A is 0, which is divisible by 4. So we have A belongs to R for all A belonging to A. So R is reflexive. So again we have done it by proof to show that it is reflexive. Let AB belong to R. So mod A minus B is divisible by 4. That means A minus B is 4k, where k is an integer. So B minus A is minus 4k. What are we trying to prove? That B minus A is divisible by, mod B minus A is divisible by 4. So we have B minus A is divisible by 4. So mod B minus A is divisible by 4. So BA belongs to R or R is symmetric. Now let AB belong to R, BC belonging to R. What are we trying to prove? That R is transitive. So we want to prove that AC belongs to R. So I have mod A minus B is divisible by 4, mod B minus C is divisible by 4. So A minus B can be written as 4k1, B minus C can be written as 4k2, where k1, k2 are integers. If I add both, I get A minus C is 4 times k1 plus k2. That means mod A minus C is divisible by 4. So AC belongs to R. So R is transitive. So R is an equivalence relation. Why is it an equivalence relation? Because it is reflexive, symmetric and transitive. So equivalence class of 1 is the set of all elements x belonging to A such that x is related to 1. That is the set of all elements x belonging to A such that mod x minus 1 is divisible by 4. That is the set of all elements x belonging to A such that x minus 1 is 4k, where k is an integer, because if it is divisible by 4 you can write it as a multiple of 4, integral multiple of 4. So this is a set of all elements x belonging to A such that x equal to 4k plus 1. So the elements will be 1, 5 and 9 because your set A has elements 1, 2 up to 12. So this is the equivalence class of 1. Now if A has m elements, B has n elements, number of relations from A to B is 2 raised to m into n. We multiply number of elements of A into number of elements of B and 2 raised to that. So coming to question 5, if A has elements minus 1, 1, 3, find the number of relations on A. So number of relations from on A will be 2 raised to 3 into 3 because it's a number of relations from A to A. That is 2 raised to 9. Question 6. Let A consist of the set of all elements 1, 2, 3. R is a relation on A defined by R is consisting of the elements 1, 1, 2, 2, 3, 3, 2, 1, 3, 2. Determine whether R is reflexive, symmetric or transitive. Now 1, 1, 2, 2, 3, 3 belong to R. So R is reflexive because A has elements only 1, 2, 3. Again 2, 1 belongs to R but 1, 2 does not belong to R. You can see for yourself here. So R is not symmetric. Again, 3, 2, 2, 1 belong to R, but 3, 1 does not belong to R. So R is not transitive. So we have used examples to show that it is not reflexive, symmetric, or transitive. It is reflexive, but it is not symmetric or transitive. So we have learned what is a relation, the types of relations, equivalence classes and equivalence relations. So this is your personalized learning. You have to practice maths to learn maths. You cannot watch it like a video. So take a pen and paper, pause each slide along with me and practice. And thank you. So join me on my next course which deals with the domain and range of a function.